All right, so we're shifting from t intervals, so we're no longer estimating mu. We're trying to make a conclusion about a hypothesized value for mu. So, Everest, why don't you put that away and take out your packet for me, okay? And so this is going to be very, very similar where we're talking about running tests for mu. So we're going to have a null hypothesis. We're going to have a test statistic. So before we had a test statistic and a p-value, we're going to check all of our conditions. The calculations are going to change a little bit, but the premise and the reasoning is going to be the same. Everybody good? All right. Battery manufacturers trying to improve the life of their batteries. The current mean lifetime of their batteries was 30 hours. They're trying to decide, have they improved? Okay. So, my null hypothesis. It's no longer about P because we're no longer talking about percentages. We're talking about means. What symbol should I use instead? Mu. What do you think it should be? Null hypothesis always has an equal sign. It should be mu is
30 hours.
Equal to 30 hours. Okay? My alternative is?
Mu is not equal. Mu is greater.
In this case, we want to know have they improved, so that would be greater than 30 hours. And of course, you guys would never, ever, ever write these hypotheses without also saying mu equals the true mean battery life after changes. Everybody good? Now, quick reminder. Type 1, type 2. What would a type 1 error be? Can somebody remind me just in general?
Like when the null is like wrong? No.
When you reject the null, even though the null is true. Yeah.
Okay, so type 1, we conclude HA when HO is true. Okay, so what would that mean in this particular setting?
Conclude that the battery life is greater than 30 hours when it is not.
Okay, so I'm going to say we're going to conclude that the true mean battery life has improved. Even though it hasn't. And what would the consequence to the company be?
Someone could sue them for fraud or lying. Battery.
I'm just going to go with they would end up lying to their customers, right? Is essentially what would happen. All right, cool.
Are you recording it?
Yes, I am recording it. Thank you. All right. What would type 2 be?
You conclude that it hasn't improved even though it has.
So what we're going to say is we fail to say they've...
Oh, because you can't conclude.
Yeah, we don't conclude the null hypothesis. So we're going to say we fail to conclude the battery life has improved, even though it has. And when I say battery life, true mean battery life has improved, even though it has. And what's the consequence to the company there?
Losing money.
Would they lose money?
They're like losing
Well, they could
Losing
charge
trust.
more of it.
They don't have the ability to advertise it.
Okay. What do you think the company would do with that?
Like they would promote it, like say, oh, we have more than that.
But they're not coming to the we have more than that.
They're like missing out on like people buying it because
Okay.
of that.
I think they would just keep trying to improve so that they can advertise what they want to advertise, which in itself has a cost. Okay. Now, if you're the company, which one's more serious, do you think?
Type 1.
Why do we care?
Because you could you could probably lose customers.
Okay. How will this influence what we do with our...
We'll lower out.
We might choose a lower alpha, because remember, alpha is equal to the probability of a type 1. So I'm going to use 0.01 for alpha. Is that okay? How do you guys feel so far? Is there anything here that's all that different? So far, the only difference really is mu instead of p. The rest of this is all the same basic premise, right? All right. All right, so they took a random sample of 15 batteries. And what you have here is a dot plot, a box plot, and we haven't really talked about normal probability plots, have we? Don't worry about that last graph. We'll talk about it at some point, but it doesn't need to be a major conversation right this second. Okay, so can we go ahead and check our conditions? The SRS is like my favorite thing ever. We were given that this is a simple random sample. All right. Normal. So, yeah, so when you say that, which graph are we looking at? A. If you said there's no major skewness or outliers from the box plot, that would be fine too. What I'd like you to do when you talk about the graph, I want us to be a little bit more specific. So I'm going to say a dot plot of the sample. Don't worry, I can spell plot. Jeez. Shows no major skewness or outliers.
And if we have the two different graphs like that, should we always use the dot plot instead of the...
You're usually only going to be given one graph. It doesn't really matter. The dot plot is not better than the box plot as long as your sample size is not like 10 or super small. If it's super small, you would want to use a dot plot. Okay. Independent, we're going to say 15 is less than 10% of all batteries from company. Again, anything new? What if I had like a sample of like 100 batteries? Would we need to check the graphs?
No, because it's greater than or equal.
Because then it would be greater than or equal to 30, so it would be fine. Okay. See, isn't this fun? Okay, great.
Yes, it does.
All right. Test statistic. We're going to calculate it by hand. We're going to calculate everything by hand first. But guys, you can also calculate it in your calculator, okay? Now, before we did a one sample z-test for P, now we are going to do I'm going to change colors here so that it stands out. Come on. We are now going to do a one sample t-test for mu. And our test statistic is no longer a z. Our test statistic is going to be a t. For the exact same reason we used a t-interval. Because we're going to end up using the standard deviation of our sample instead of the standard deviation of our population. Remember this from last week? Okay? We use t because S is a crappy estimator of sigma. Okay. So, test statistic, if we look on our formula sheet, the test statistic is supposed to be our parameter. That's a lie. That's 100% wrong. Is statistic. Come on. Guys, what's wrong with me? Minus parameter over standard error. Yes? What is our statistic in this case? It is X bar. What is our parameter in this case? It is 30. What is our standard error? It is S over the square root of N. So to calculate our t statistic, we are going to say t equals 33.9 minus 30 all over 9.8 over the square root of 15. Yes?
Why is the parameter the null hypothesis?
Because it's your, like, remember that we do this, remember the parameter is the measurement of the population, right? And when we run a hypothesis test, we assume that the null hypothesis is true. So we want to use the parameter because the whole idea is we use that t to find that probability we could get that sample, assuming the null is true. So the parameter, if the null is true, is 30. It has to do with the fact that the whole reasoning goes with we assume that the null hypothesis is true, so the null hypothesis would be our parameter.
Oh.
Like, because we use this test statistic to calculate our p-value. That's the whole point of calculating it. Hey, what are we getting?
1.54.
I'm sorry?
1.54.
1.54?
Yeah.
Okay. Everybody feel okay about this? Give or take? All right. So, the next thing we have to do is calculate our p-value. So let's draw a picture of what we know here, okay? What we know is the t statistic of our sample. So I want to go back to that t graph, just like when we calculated t stars. And what we always wrote down was the mean of our t's, which is 0. Because the mean of all the t graphs, just like the mean of all the z's, is 0. The standard deviation we never write down. Instead, we write down the degrees of freedom. What is the degrees of freedom for a t graph? N minus 1. So what would it be for this t graph?
14.
Okay. And then I can do my 1.54, and I'm going to shade to the right.
Wait, so the t statistic is, like, why is it t? The t in the graph?
Because what I put on the graph was not the mean of my actual sample, it was the t statistic of that sample.
Which is just like a term to describe a certain aspect of it.
Sure. In the same way that z was just something that described something. T is very similar to z. So a z star or a z statistic of 1.54 would mean that that sample is 1.54 standard deviations above the mean. T is mostly like that, except for it's not as reliable as z. But we use t because we shouldn't always use z.
Do you have Volks on this class?
She's in first period.
How? Have a great one.
Later.
Bye.
Is this okay? Does anybody? So normally we would use normal CDF here. Can we use normal CDF here when we don't know the standard deviation? Can you go into your distributions menu and see if there's something else we can use? Oh, that's weird. There's a TCDF?
What does the PDF stand for? Because it just sounds like, like a computer, like PDF.
Okay, so CDF is the cumulative distribution function. PDF is the probability distribution function. PDF gives you, because this is actually a function, right? And here's your y-axis, here's your x-axis. PDF gives you the height at that one value.
Oh, that's cool. Are we in CDF?
But you wouldn't.
Yes.
But you wouldn't.
You wouldn't use it.
You wouldn't use it because you want the cumulative. So when you do the CDF, what it does is it finds the area to the left of the upper minus the area to the left of the lower.
Mm-hmm.
So both cumulative just means that and below. So you're basically finding this area and this area and subtracting the two. What are we getting? 0.07? Okay? All right, now, not what conclusion can we make, but if I asked you to interpret that value in context.
That means that that's the percentage of, that's the probability that you're gonna get it. You're gonna get a sample that's too big, so you're gonna reject the null hypothesis, even though the null hypothesis is true.
No.
Okay.
Okay, the p-value. It says, hey, the whole purpose of the p-value is we start by assuming the null hypothesis is true. Okay? So to interpret that p-value, I'm going to start with if the true mean battery life is 30. The probability Come on. Why is probability so hard to spell?
It's like necessary.
I just spelled wrong on purpose.
Good for you, Emma. See, I was thinking that, I just didn't say it.
Great idea. Oh my gosh, wait. Did you hear about like the world of like that thing like
Oh, where you guessed the country?
yeah, it was really fun. I got it in one yesterday. I also got it in one yesterday.
How do you do that?
Because
You go
Emma
world?
was such a kind person and told me it was not one specific
Everyone-
country.
Okay.
How do you do, what is it called, world?
We'll get it at the
Yeah,
later.
Yeah, there's going to be like...
in the middle of class.
I
I was
was
asking
asking
you about it.
All right. Hey, guys.
If you got it,
What conclusion can we make then?
We cannot. No. Yes.
So let's start with since.
Greater than alpha, though.
0.073 is greater than, remember, because that type 1 error was more serious, we wanted to use 1% as our alpha. Okay?
So true.
We can not reject
I always get messed up.
the null hypothesis. Therefore, we cannot conclude the true mean battery life has improved. Is this bad?
No.
Can I make it worse?
You preferably not.
Hey, real quick,
Well,
guys, in your calculators. If you go stat, can you read this? Can you guys read that? No. No. See if we can't find some better lighting for you. This is 100% here. Can you guys read that now?
Yeah, totally.
Crystal. Better? And then we'll just do.
The last
Is that okay? Is that good? Stat. Error over 2 tests. What do you guys think we should pick? T-test. Option number 2.
Really?
Okay. I can do it from the data. Or I can do it from the summary stats. Do we have the raw data where we can type it in to a list? No, we're going to pick summary stats. All right, so that first one was, what is my null hypothesis? What is my null hypothesis? 30. What was my X bar? 33.9. My S was 9.8. My sample size was 15. And my alternative hypothesis was greater than. I go down to calculate. It gives me T equals 1.54. Well, that tracks. Gives me a p-value of 0.073. It's going to match whatever your alternative hypothesis says. No, remember, you're saying is that the mean is actually greater than the 30 of the null hypothesis. It always matches your null hypothesis or your alternative. Is everybody good?
Look at the graph.
Yeah, let's look at that graph real quick.
Look at that graph.
When you look at that graph, y'all, and if I hit draw instead of calculate, pay no attention to the other function that's currently graphed on my calculator.
It's okay, I'm in parametric mode.
Oh, what just happened? I can't even.
Doesn't that graph look very similar to the graph we have drawn? That's because you have a function graph too. It looks like you might have a very similar function graph,
Oh.
which is kind of crazy.
Y equals and clear it out.
That's all it is.
Oh.
Is you have a function
Oh, yeah.
graph from pre-calc.
Oh yeah. It's
we're not
a
learning about
X
function
cubed
graphs
and
in
then that other
pre-calc,
thing.
though.
When was the last time you used your calculator? Like it would have. That could have.
That's true.
Okay.
I'll
Okay. Is everybody good in terms of? Do you have to do all of these calculations now? Why do I always end up showing you these? Because
There's gonna be a question about it.
there could be a question about it. So I'm going to show you how to do it by hand, but your calculator's going to do it for you. Okay? Everybody feel good so far? All right. I think I made a little bit worse, don't I? Ooh, yeah. You guys want to talk about pineapple?
You know, pineapples in America got imported to America from
Got Hawaii annexed. That was the reason
Stanford
for
Dole,
Hawaii being annexed.
who was a plantation owner that went to Hawaii to grow pineapple.
I know. How was it? What do you
Actually, it wasn't that bad because we talked about Big Bertha, but
Big Bird.
Okay, y'all. Hey, look, what a great opportunity for us. Okay, so at the Hawaiian Pineapple Company, managers are interested in the sizes of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested was 31 ounces. A new irrigation system was put in. I'm going to stop reading this and let you guys just read it. Is that okay?
same here. I think you should keep doing it.
A new irrigation system was installed in this field after the growing season. Managers wonder whether this change will affect the mean weight of future pineapples. To find out, they select and weigh a random sample of 50 pineapples from this year's crop. The Minitib output below summarizes the data. All right, you guys ready? Are there any outliers? Because I'm sure you guys remember how to calculate if there's outliers, right?
It's 1.5.
IQRs, which is the Q3 minus Q.
Okay, so the first thing we need to do is find the IQR,
I forgot about IQR.
right?
This is unit 1.
Hey, this is from technically the second unit you learned, but that was unit 1.
Years ago.
I understand.
Last year.
Why do you think I put this in the notes to start reviewing some old content before the AP exam? Okay? Like, I'm not trying to be a jerk. I'm putting it in the notes that I help you guys through, yes? Okay. What is the IQR, guys? What do I do?
Q3 minus Q1.
So Q3 is 34.115. Q1 is 29.990.
4.125.
What is it?
4.125.
Okay.
And then don't we multiply that by 1.5,
Okay.
We do?
right?
So 1.5 IQRs, we do 1.5 IQRs for sure, would be 1.5 times 4.125.
Don't you need to do like a minus? I guess there's one.
Just Can we just breathe? Can we just
We
breathe?
don't know where the points are, so how do we know what the
Well, it
points
says the
are?
maximum's right there.
We get the Q1 and
Oh,
the
the
Q3.
maximum.
Go read the whole
right.
chart.
Hey guys, can somebody type this in and help me out?
6.1875.
6.1875. Perfect. Okay. Now, something is an outlier if it is too far away from the other points. And the way we define too far away is the 6.1875. It's 1.5 IQRs too far away from that middle chunk of the points. Okay. In other words, from Q1 and Q3. So if it's too small, if it's a small outlier, what I need to do is I need to take that Q1 and subtract that 6.1875. So it's either too far below Q1 or it's too far above Q3.
It's not.
What are these answers, y'all?
The first one for Q1 is 23.8025, and the second one is 27.9275.
20s? No.
What? I got 40.
It should be, it should be
Oh,
bigger than
plus.
34. You accidentally did the minus. Again, what is it? You got 40 and some change?
Yeah, 0.3.
40.3, okay. So do we have any outliers?
Is the minimum and the maximum, right?
The minimum, so this is smaller than the minimum. And this is greater than the maximum. So we have nothing outside this range of values. So no outliers. I haven't seen outliers. I've seen it once in the past 20 years, and it was 2 years ago. The probability that you're asked about outliers, relatively small, but just in case, here's our reminder, okay? All right, so do these data suggest that the mean weight of pineapples produced in the field has changed? Give appropriate statistical evidence. The minute I hear,
That language sounds weird. Do these data?
I know, but data is technically plural.
Oh.
So wouldn't it be does the
Technically, the singular is datum.
Oh.
But don't worry, nobody really cares. It's fine. Okay, so guys, let's walk through this test. Does anybody want to tell me what you think the null hypothesis should be?
Don't we have to name the test?
Sure. It doesn't, like, in theory, okay, so technically, what I would say is that you write your hypotheses first, then you pick the procedure that's appropriate to test those hypotheses. In the grand scheme of life, it doesn't matter. But theoretically, what I might do is say, hey, my null hypothesis is that the mean stayed the same. And my alternative is that the mean increased.
That should be your third dog's name.
Data.
Emma.
Let's make sure this is clear. Miss Meister's never having 3 dogs again. It's an insane amount of dogs.
Hat, X bar, datum.
I'll just name a mean and median.
They get mixed up.
Okay. Everybody good? Anything else you want me to write down related to this? Mu equals the true mean pineapple weight. Okay. And with those hypotheses, guys, what procedure should I use?
One sample.
T-test.
A one sample t-test for mu.
And then we can do the random.
Hey guys, I think I said the word random sample up there, didn't I?
Yeah.
Yeah, given all them
Yes, it's greater than 30.
Normal.
50 is greater than or equal to 30.
My sample size is 50, which is greater than or equal to 30. Perfect. Independent.
50 is less than 10%.
Let's hope a farm is coming up with more than 500, right?
Yeah.
So 50 is less than 10% of pineapples from that year. Okay, now what?
And then we calculate.
Go ahead, do some calculations for me, y'all.
Hooray. I don't really know. You go to 2. She literally just told you the instructions like a page ago. Like.
Relative standard error, so that's gonna be all 339. Did you times 10 to the negative 25?
No, I didn't. Why did I get 0?
I got 0, but I typed in the wrong numbers.
That's what I got, y'all.
Oh, you actually got 0? Oh, no.
No, I got 0, but it's
I got
31
so
instead of
excited.
31 point whatever, and then the wrong number for the standard error.
Oh, cause I got
Oh yeah, the
4.836
standard. I put CB.
times 10 to the negative 25.
What did you use for, guys? So this brings up a really important point, okay? All right. Did anybody use this value?
Yeah,
Yeah.
So
Were we supposed to?
no, you were not supposed to use that value, okay? Because what the calculator is asking you for is the standard deviation of the sample, S, not SE, okay? And it turns out, guys, here's what I'd like you to do. I would like you real quick on the side, do 2.394 divided by the square root of 50. S over the square root of your sample size,
Where's 2.394 from?
the standard deviation. I bet you get pretty darn close to 0.339. Am I right?
Yeah.
So it's really easy. And it's the reason this is here. It's the reason I baited you guys into doing this on your own. Because I want to make sure that we're understanding what we're being asked for. Okay? When your calculator asks you for S, it's saying what was the standard deviation of the sample itself. Okay?
I got a different P than you, but I put in all those numbers. But
What did you
I
get?
did the same thing.
I
but
got
switched.
0.995.
No, Emma, that's what I got, but I realized I switched X
You
bar and U, or mu,
You have
in my.
your
I had
alternative
31 in the
just
wrong place,
way.
and then I just okay.
Is this okay? Can I not worry about this anymore? Okay.
I still have it to
Go back.
You have the wrong S.
I copied it from the.
It's 2.394. Is the standard deviation, not standard error.
But I did that, this.
Yeah, but your calculator, when your your calculator wants this number. Your calculator already knows it's like pre-programmed with the formula to do that t-statistic, right? So that's why it asks you for n. It needs the stuff that's in the formula to calculate that t-statistic. Any questions? All right. So, guys, what's our conclusion? Since 0.004 is less than 0.05,
We can reject the null hypothesis.
now we can reject the null hypothesis. And if I reject the null hypothesis, how many hypotheses do I have left? I only have one hypothesis left, okay? So therefore, we can conclude the true mean weight of pineapples has increased.
I know, the amount of times I would rip them.
What do you guys think? Is this okay? All right, so can we say with certainty that the irrigation system is what caused this change in mean weight?
Could we do like a sampling of the subtracting the confidence intervals above weight?
We can say that the weight has definitely changed and that the second year definitely had a higher weight than the first year. Okay? That's what we just found out. Can we conclude that the irrigation system is what caused that change?
No,
Why not?
correlation is not causation.
Okay. What is necessary for us to conclude that the cause and effect in general?
A control
Only
group,
one variable.
a control group of the same year.
Potentially, you're getting there. Randomly assigned treatments, yes? Was year 1 to year 2 randomly assigned? Or are there some other potential lurking variables that would have gotten in the way? Would anybody like to suggest one?
Grasshoppers.
Tsunamis.
It grew in weight. It can go down. Like there could be more fertilizer
More rain.
or
Or what
like
if there's
more
a tsunami
rain,
in the first
more
year?
sunshine.
More rainfall.
Okay. Probably more sunshine than more rainfall because it's an irrigation system that they wouldn't, right? Right? Maybe they used a different fertilizer from one year to the other, but yeah. So okay, so how could they have set this up differently so that they'd be able to say it was the irrigation system? What should they have done?
Have some pineapples that aren't in the irrigation system.
Okay, maybe have like, I don't know, 10 different plots and randomly assign. Is everybody with me? Okay, so no randomly assigned treatments. The crux of the question is no randomly assigned treatments. I really like examples to kind of talk about what the issue is, okay? Weather, different fertilizers. Crop rotation, who knows? There's something that could have had like some other issues, okay? We still doing okay?
Yeah.
Oh my God.
Last page.
Last page. And
Oh, okay, you scared me for a minute. We still have a few more.
No, of today.
of today. Then we're going to do a little bit of an activity, then you're going to get your review. Okay. I'm going to let you guys read this.
Oh my God.
I feel like this is like human experimentation.
is human experimentation.
They
They volunteered to do this.
Okay. All right, so. Why did we randomly assign the order?
So we could
Generalize to
For
those
correlation.
types of people.
but it's volunteer, we can't generalize the population.
We can't generalize to the population because we have volunteers. However, if we randomly assign the order,
Causation.
we're allowed to determine causation. Okay. What kind of design is this? This is matched pairs. We're going to do a paired t-test. Okay. Now, I got a great example about why we randomly assign the order. How was your day yesterday?
Wonderful.
Wasn't it?
Good.
It was a beautiful day, right?
Yeah.
How's your day today?
It was okay. I have a headache. I'm not doing so much.
If I gave the placebo yesterday and the caffeine today, could that influence y'all's moods?
Yeah.
I mean,
Well, then yesterday I wouldn't have really made, but then today I'd be like, yay.
Did anything else happen yesterday that might have people in like a more kind of mood? A little anxious?
No, not really.
Russia, Ukraine.
Oh, I forgot about that.
There's plenty of, do you guys see what I'm saying? Okay. So we don't want major outside events. Won't be confounding variables. Because in all seriousness, guys, I was in the world's greatest mood yesterday. I woke up this morning and I was like, ugh. Now, some of that was because I didn't have to work yesterday. And I do have to work today. But the majority of that was I literally opened the back door and the dogs pretended to go outside and came sprinting back in, right? Like they want to be, when my dogs don't want to be outside, something isn't right.
When was that?
Today.
This morning.
Today was
Yesterday they didn't want to be
It
inside.
was like last night at like 12 a.m. or something. We're like
There was it was I can tell you exactly when it happened. It happened at 3:30 a.m.
I woke up and I woke up to one.
There was a crazy clap of thunder.
Yeah, and it was so long too. And I like woke up. I was like, what the heck was that?
I sat up bolt upright in my bed at 3:30 a.m. because of a very loud bang.
Opened my eyes because
Oh,
I
the Nicki Minaj.
Okay, guys.
It was raining, so my window was open. I was like, oh, I gotta go close that.
They're promoting
All right, so let's do the paired t-test. What should I do first?
1, 2 sample?
No.
One sample.
It's just matched pairs.
Before I do any of this, you know what I want to do?
What is zero? Yeah.
Before I do that,
The null.
I'm going to find the differences for each person, right? Since we're allowed to compare each person to itself. Now, it doesn't matter, but do you guys want to do caffeine minus placebo or placebo minus caffeine?
Placebo minus caffeine.
Okay.
Yeah.
Not all. For most of them.
Well, yeah, most of
I'm
them
pretty
are.
sure every single
All of them
one.
are.
Every single one. No, right?
I don't think it's every single one.
No, I think it is.
I think it's not.
But they're also.
Oh, besides the
Oh,
last
except for
one.
11.
Yeah.
But they're not even depressed, so.
So loud, girls. They're not even depressed. Like, can you calm down? Yeah.
Yeah, what's up with number 6?
24.
And number 2.
It's literally my mom, and she has to deal with this all day.
With no
She
caffeine.
had 5 cups of coffee yesterday. 'cause
Oh
we
my
were all
God.
home.
Oh.
Your poor mom.
Number 6 is even more extreme.
Like 3
than number
kids,
2.
especially with you 3.
Ow.
Yeah.
Okay,
I was an angel yesterday.
Sure you were.
hold on.
What is this depression scale?
All right, so what is my null hypothesis, you guys?
That's greater than 1.
It's
Or greater than 0.
It's 0.
My null hypothesis?
Oh.
And guys, I'm going to write this as mu d is equal to 0. Okay, because whenever I'm doing one of those differences, I like to throw that d there as I know that it's a difference. All right, now, be very careful about what we think about this next one, okay? We did placebo minus caffeine, but then I want to point out this one thing. higher scores show more symptoms of depression. Okay? So if we want to show that the drug works, we want to show that the drug, I'm sorry, if we want to show that the caffeine lowers depression, we want to show that the caffeine group is lower, which means placebo minus caffeine will be greater than 0. But you have to be really, really careful on that sign, y'all. Okay? And then we're going to say mu D equals the true mean difference in depression score. Placebo minus caffeine. Cool. Random?
Shouldn't we state the test?
Oh, yeah. Thank you. What test should I do then?
One sample t-test.
A matched pair.
Paired t-test. If you put one sample, it won't be a big deal. For mu D. Okay? Random. And that is, order was randomly assigned. We already talked about that above. Normal?
Oh, do we have to plot
And what should we plot?
the difference?
The differences. Now, before you guys get irritated with that, I would like to remind you, it's a very small group of numbers you have to plot, okay?
-1 to 19.
-1 to 19, so I'm going to count by 5s.
Good afternoon, everyone. For most of you, today is just another Tuesday, but to the math geeks, today is special. And at the sound of the
Oh, it's two.
tone, it will be 2 hours, 22 minutes, and 22 seconds in the PM hour on 2/22 of the year 2022, namely a Tuesday. Enjoy it, because it will never happen again.
At least,
Thank you.
He's saying it like it's so cool.
it is super cool.
No, like he's so
Okay,
happy
I
about
screenshotted.
it.
Yeah, I
That is true.
Okay.
So true.
I gotta get that screenshotted.
I
Never again. There we go.
All right.
Screenshot. There we go.
I did not know Mr. Richards said that. I thought that was someone else.
Hey, guys, talk to me about independence here. Can we do 10%?
No.
Because this is not random samples. This is a group of volunteers. So we're going to say individual depression scores are independent. Though, again, we're going to assume that they don't talk to each other and stuff when they come through.
Yeah, but that makes me more.
So, for example, on a day like today, Ms. Meister on a placebo could definitely influence your depression scores.
So true.
Okay. Now, can you guys help me find the T statistic and p-value?
Wait, so should we put it in the,
Mm-hmm.
The list.
yeah.
Everybody good? Do we all get this? All right, you guys ready for my next question? You're gonna hate it. What if we had done caffeine minus placebo? What about this would change? What would be the same?
Would it be negative?
Would what be negative? T would be negative. What else?
The alternative hypothesis for it if you split.
The alternative would have to be less than. Okay? What else?
The normals, like graph.
The whole graph of the differences would be negative numbers, right? As would X bar. X bar would have ended up being negative because we would have had a whole bunch of negatives and one positive. Okay? So if you had done this difference in the opposite direction, Ms. Meister is capable of making sure it makes sense, is what I'm trying to say to you. Okay? And let's make our conclusion real quick.
Since it's less than 0.05.
Since 0.003 is less than 0.05, we can reject H0 and conclude
That caffeine,
that caffeine, that the depression scores, I'm going to say it this way. Caffeine causes, because we want to conclude cause and effect for people,
Lower depression scores.
causes lower depression scores than the placebo. For people like those in the study.
Do we have to put anything about mean in there?
Not in this particular case. If you did, it wouldn't be bad.
So technically, a bunch of people, like adults, could be depressed, but like since caffeine, like is in
Yeah.
their lives, they're not.
Yeah. But keep in mind, we don't know that, like, I stole this from a textbook. We don't know how real this data is.
It might be real.
However, it's also like, I don't want you to, because there's a confounding variable of depression versus addiction. You with me? Because like, with me, I don't think I'm a depressed person. With you, I would definitely have depression-like symptoms if you took my caffeine away, particularly in the morning. Right? And it's not because I'm depressed, it's because you took away my lifeblood. So here's what we're going to do next. I would like to have a little competition between you guys and